Okay, today we will be discussing our prior knowledge. It connects very well to last chapter. So if we look at this first example, it says an architect draws plans for windows. What is the scale factor? Well, remember from last chapter when we did the dilation, we used that the scale factor was equal to the image that we created over the original. We're going to use that exact same idea this chapter for scale factor. They just use a little bit different wordage. So scale factor, the image that is created, they are going to call it the scale drawing. Sometimes those get bigger and sometimes those get smaller, just like for a dilation. The original is called the actual. So you can either use scale over actual as the words, or you could use image over original, and I would understand what you're talking about. So the scale drawing is 8 inches over the actual, which the actual is 72 inches. So the second step then, after you set up the ratio in step 1, is to go ahead and reduce that. The good news is, because they both have the same units, the units cross out and we're left with 8 over 72. That reduces to 1/9. So my scale factor is 1/9. It makes sense that it is less than 1 since the scale drawing got smaller than what the actual window was. Our second example is asking us to find the length. It says a painting is enlarged by a scale factor of 2 to make a poster. Find the length of the poster. Step 1 is always going to be to set up our ratio. So again, we have the scale factor is equal to the scale over the actual. And I'm going to fill in the things I know. I know that the scale factor is 2. It makes sense, it's larger than 1 because our window got bigger. The scale side, the new window has a scale side of X inches. So I don't know it, that's what I'm looking for. The actual window though started out as 15 inches. Since both of those are in the same unit of inches, I don't have to worry about those, they would cancel out. So now I solve my equation for step 2. To solve this, I would take both sides times 15 to get the fact that X equals 30 inches. A lot of you would be able to do this one without setting up, just knowing that it's times 2. 15 times 2 is 30. But the reason it works is by setting up this equation. That's how you would get the answer. Our next example then here is finding area. Find the area of the poster in example 1. So this time we're doing area and not just side length. So we have to remember some things about area. When we take the area of different things, we take, let's mark this as X and Y. X, my pen's not working for me, X and Y. When we find area, we would do X times Y. And same thing over here, we would do X times Y. And this is X primed Y prime if you want to think of it like last chapter. Well, if they are both doubled, that means we would take the double of this one times the double of that one. So that means it would be 4 times then as large for the area. So if I read here, it says if two figures are related by a scale factor of 2, the areas are related by a scale factor of 2 squared, because this side is doubled and this side is doubled, so that would represent the 2 squared. So to set up my equation, I would do the following. The scale factor of my area, 2 squared, is equal to the scale of X, or in this case, sorry, the area is Y, inches squared, over the actual, which is 150 inches squared. Again, they are both the same unit, so I don't have to worry about that. The inches squared just cancel out. So now to solve this, 2 squared is 4. So I get 4 is equal to Y over 150. The opposite of divided by 150 is to take it times 150. And we end up with the fact that Y is equal to 600 inches squared. Your assignment that goes with these notes is the following: Scale 27 and 28 worksheet.